We're going to do 2 videos about creating new functions out of old ones. Of course, we want to be very familiar with our starting building blocks of functions, but we also want to figure out how to take them and create new ones. There's a few ways that we've really been doing for a long time that we've combined simple expressions, algebraic expressions, and we just have a new perspective on that. And that's just using algebra to create more complicated functions out of simpler ones. So if we start with 2 functions, f and g, I want to symbolize those. We'll get to an example in just a second, but I want to symbolize those as some sort of box, some sort of machine that takes an input, spits out an output. And if you have an input x, and you've got 2 things you could put that into, you can put it into both of them, create f of x and g of x, and then combine them just by adding the answers. So a really simple example of that would be f of x equals x squared, g of x is 2x plus 1, and the sum function, so one operation that has multiple parts to it, to figure out what that does to any particular input x, you just put x into each of f and g, and you add the answers. And that seems a little abstract, perhaps, but it's exactly what we would think of. I don't think I've ever had a student who gives me a different answer. If I say add x squared, the function x squared, and the function 2x plus 1, everybody just puts a plus sign in between them. And that's totally right. That's exactly the right thing. It's just adding those expressions. And we've been doing that forever to create polynomials and all kinds of stuff. Okay, so it's not really anything new. Let's look at what that looks like graphically, though. We want to get good at graphing functions. So f of x equals x squared. We want to be really, really familiar with that. That's simplest example, what's called a parabola. F of 0 is 0, f of 1 is 1. Notice the scale here. F of 2 is 4, f of 3 is 9. It's just a little bit off the scale, I think there. 2x plus 1, okay, that's g. G of 0 is 1, g of 1 is 3, g of 2 is 5, straight line. It has slope too, but notice the scales are not the same, so it doesn't look very steep. So what happens if I add those together? Well, first I'll just put them together on the same graph. And then to add them together, it's not incredibly easy to picture that, as it turns out. Even though adding 2 functions algebraically is just so simple. You just write them down with a plus sign in between them. Adding them graphically, you have to think about a bit. And so let's do that for a few values. For example, if I plug in 0, f gives you 0 and g gives you 1, so the sum is going to be 1. That's going to be this bold, this thicker line. If x is 1, f is going to be 1, g is going to be 3, and so that's going to be a little higher. It's going to be 4. If x equals 2, the x squared, the f function gives me a 4. The g function gives me 5, and then that's already up to 9, just a little bit off the screen. Over here, for example, at minus 1, x equals minus 1 squared is 1, but 2 times minus 1 plus 1, that's a minus 1. Those exactly cancel out, and so when you add those plus and the minus, it actually ends up right in the middle at 0. One more, f of minus 2 is going to be 4. G of minus 2 is minus 3, and so it's recovered a little bit. It turns out to be the sum is going to be 1. Kind of interesting that what's actually happened by adding this kind of tilted line, what it looks like is this parabola seems to have been shifted over to the left. That's kind of unexpected, right? If I drew just the 2 parabolas, this original curve and the darker one, you might guess, oh, what I'm talking about is a shift, and we're going to talk about those in very, very soon in another video. But it actually was the result of adding this linear function. Let me just show you why that's true. So x squared plus 2x plus 1, there's this thing we know how to do, which is called completing the square. And in fact, I chose this to be just this guy. Turns out, we'll discover that if you take x squared and you do a substitution of putting x plus 1 in here instead of x, you exactly do get a shift. But that's just a little bit of a preview. The main thing is that systematically we can go through, and for each x value, we can just add the 2 heights of these curves. And we might get something a little bit interesting, a little bit unexpected. Okay. So I don't really want to make this video very long because, again, algebraically, this is not really anything new. You can subtract functions, you can multiply them, you can divide them. You have to be careful because you might end up accidentally dividing by 0. But it's just, algebraically, it's just putting the two things together. So, for example, if f of x is x squared minus 3x, and g of x is x cubed plus x squared plus 1, a little bit more complicated, then we would say the quotient of those two functions is the function that when we put in x, we just create this quotient. We've been working with this very recently, and you've worked with it before. Just we would have called this a rational expression before. We still are going to call it that, but we can also think of it as a function built up out of these simpler functions, which are polynomials, by dividing the outputs of the two functions. Okay, and then next video for a more fundamental thing called composition.